Okay, we are live. And here is a quick context on what we're doing. We're making game in plain English. Here is a quick example of plain English. It's literally like create a window, initialize gleft window. It's as if programming with comments, but they're dynamic. Here, look at how it's the same line. It's the same line, but there's space for arguments that makes it different. And you can like make a whole game in doing it in this way. On the top right, we have our application for speedrunners, but I'm using it just to organize the whole content on what's going on. And here from last time, we made our project was rendering 50,000 blocks with 40 FPS. This is what we did last time. Today we will make the breakout game. This is the original breakout game, but this is what we will be making. Bit modern version. We are following the best resource on OpenGL, the resource that I also learned from. And let's do this. I will start with a fresh folder. We will start from a fresh folder. So all of this will be deleted. We'll be starting from scratch. And I'll even give some context. Let me save this. Last changes from before, and we will delete most of this. We will delete most of this. Okay, let's go to window. Okay, now our focus is to make the window. And let's start this. Yeah, we will start by cleaning up here, and let me check Twitch. Twitch is complaining that has too much bitrate, but I'm giving it exactly 6,000. Weird. Okay, now let's clean it up here, and you will quickly see how all of this works. Let's all right, so here we are declaring a function. Like here, all of this is just your regular includes. This is your regular includes, where here I'm including shader, block, player, ball. We don't need that. We'll make our own. Processing input. Here for process input, I got the player, but we'll ignore the player. We'll ignore these. And here this function is called process input. You'll see where it's called. We'll ignore it for now. Declare float array. These are the vertices for testing. Yeah, we'll leave those. And here is the starting point for the program. So it's int main, the function. The main function that returns an int. These are just called every time when you create an OpenGL project. It's just window setup and to initialize OpenGL. This on the resize, we can just delete it. We don't need it. Here we are creating shader program. No, we don't need it. This we don't need. We don't need this. And this as well. Call process input. Here is the process input we saw from the start. Background color. This we don't need. This we don't need. And here it is. A clean start. Let's try to run it. It should open a window with just a black background. And here is how I've made a compiler from English to C++. So here I call the command translate, and I have to give I have to pick a file, rules, and now it has translated into main CPP, giving some kind of error. Okay, it's giving error for process input because I'm giving argument player as well. And now it upon save, it automatically compiles to C++. And now with F3 I run it, and we'll wait. And here is the window. It's using this color. Set background color to bluish green. This background color is set here, geo clear color. I can actually, before we change the color to black, for example, we can see the rules. Here is how the compilation actually works. Here it is. Like, this is really simple to understand. Include OpenGL. And here to the right in my rules for include OpenGL, I have this. So it's literally just copy pasting from my rules that I've predefined. While I learned OpenGL, I just wrote all of these. And here is just copy pasting them. Isn't this inefficient? Well, that's why we have these dynamic copy pastings. So here, with arguments, here, for example, where we can call a function, here we can input the function name and it pastes it here. We are telling it where to paste it. And here the arguments, they are pasted here. And I have all of these rules just for making a game from scratch. So let's make one. Geo clear color. Set background color, and here we will change this. Set background color to, we'll change it to color. And here we'll change this here color. And now this will no longer work because there's no rule like this. We'll change it. And here, look how I have auto completion. If I press tab, now I can change this here to the actual color. Let's set it to black and F3. And now we have a black screen. If I press escape, the window closes because of our process input function, this one, which just checks if the escape key is pressed and closes the program if it's pressed. And here, when we where is this array of vertices, we can ignore it for now. So this starting point for program execution is just the main function. And Let me open both chats so that I can interact with you guys. Pop out chat. This is the first chat. And then from Twitch, pop out chat. Okay. Now I can see if you guys comment something. And here, this is the starting point for the program. And in it, we do we call the regular functions that we have to call for every OpenGL project. Here it's initialize GLF W window, create window. Actually, for create window, we will give an argument, create window with title, and here I want access to the actual title. And here for create window with title, breakout game. And now when we run it, we have a window with the title breakout game. And we initialize glad so we can call up NGL functions. Like we call these functions only once and we ignore them afterwards. Tell OpenGL the size of the rendering window. This is standard. This we can, by changing this function, which is I think GL viewport. Yeah, GL viewport. We can change the function to just render, for example, here in the left side or right to the right side. But we're just saying to render to the whole screen. Like this is standard stuff. Here start render loop, which is just a while true loop. While the window is running, we do our rendering here, all of it. Here we call the process input function, which just checks for the escape key, and if it's pressed, we close the program. Here we set the background color to black. And here we swap the currently shown buffer with the one we finished working on. So we have two buffers, the one that is currently showing and another that we're working on. And when we're done with it, so we've reached the end of the while loop, they swap. Just so we are not drawing and rendering on what the user is currently looking at. And here check if any keyboard or mouse events are triggered. This is, I think if we don't have this, the window will not be reacting at all. Like here, look at the mouse, how it's loading. I cannot interact with the window. That's why we need this line here. So that's the context. And now let's actually make the window. Let's make the yeah, we've actually like we already have the window. So that was the window and context. Let's now focus on making the blocks. These blocks here. So if we go to levels, these blocks, and these blocks are actually distinct. We will not have the blocks that cannot be destroyed. We'll keep it simple. We'll just have these blocks. And to have these blocks, we'll just use this one. We'll just use this one. And actually, let me see which folder it's in. Reveal in File Explorer, copy, and we download this texture and save it in resources. Internet speed For some reason, OBS disconnected. I'll check the internet speed. I don't know why OBS disconnected. Yeah, we have internet access. Like, it's really weird why OBS is connected. Okay, it looks fine now, so we'll continue. It's just that the Twitch stream is offline, but I'll just start it, so no worries. Twitch bitrate. Oh, I see. What's the issue? We will change the bitrate 1 minute. 1 minute just to change this. It has to be 4050 because we're running at 30 FPS. Yeah, we'll leave it as that. For making the blocks, we want, first we need a shader. Let's first render a triangle. We need a VBO, VO. We need a shader. Let's first make the shader. Shader. Vertex shader source code, declare string with name. Yeah, okay. So first we will declare string with name vertex shader source, and the value will be, and the value is, oh, we can actually do it in one line. Vertex shader source code. And we need one for fragment shader source code. And here it's fragment shader. Okay. We have the source code. We need to create an object, shader object. We need a shader object. Yeah. So here, create vertex, create vertex shader object. Vertex shader with source code, vertex shader source. And what else we need? We need to compile it. Compile shader, vertex shader. And we need this, we need to check for errors. So before we check for check, what did I call it? Yeah, if shader, if vertex shader doesn't compile successfully, write message, vertex shader, just vertex shader for error message. And for this to work, we need to declare variables, and we will just declare them here. Declare variables to store shader compilation errors, and they're just this in success and char info log. Success is just to store whether the compilation was successful or not, and info log just to store the actual compilation error message. And now we need to compile the fragment shader. And here, fragment shader source. here compile fragment shader, and here to check if fragment shader compiled successfully. And now we need a shader program. Let me check if the bitrate for Twitch is enough. It's saying keyframe interval too high. Weird. No worries. I hope that Twitch experience is alright. If you're having issues in the Twitch stream, let me know. I'll see what I can do. But the YouTube stream should be perfect. Okay. Now let's create the shader program. Yeah. Create shader program. Yeah, but we need, look at here how it's create shader program and it just sets a variable to it. We need to declare the variable as well. Declare unsigned int. So variable shader program shader program of type non-negative whole numbers, and shader program. And now we need to create the shader program. Shader program. Activate shader program here. Okay. So create shader program and store in shader program. We need to attach. Yeah, we need to attach the shaders, the compiled shaders. So first the vertex shader to shader program, and then the fragment shader to shader program, and we need to link them. We need to link the attached shaders, and we need to check for if there were errors while linking them. Here, check if shader the program. Here we need to actually give it shader program name, and here we need to set it as argument shader program name, and in here check if shader program linked successfully. All of this just to create the shader. We have the shader. Next, we need to start rendering. So we need our vertices. Do we have vertices here? Do we have any vertices? Yeah, here we have some vertices. They also have texture coordinates. Yeah. Color and texture, perfect. Yeah. And there are only 4. That's not all right. They should be more than 4. If there are 4, we need to use an EBO, but for such a simple game, we don't need a VBO. We'll actually change these vertices. So the vertices, how OpenGL actually, yeah. So how OpenGL handles coordinates, because the origin is at the center, and I think here it's like here up and down is the y-axis, and left and right is the x-axis, where here it's plus and here it's plus. So when we say 0.5, 0.5, that should be here. And 0.5 minus 0.5. So this should be here. And this should be minus minus down and to the left. And the other should be up and left. 0.5 minus 0.5, 0.5. So these are the vertices, but we need to repeat some of them because in OpenGL we draw with triangles. So we are saying like this is the first one, second one, third one. So this is the first triangle, and we need to repeat these two that are both positive and both negative. Both positive. No, it's yeah. So we can paste it here, and we can copy these, paste them, and yeah, now there are 6. So what I did is the ordering right here, 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 here. Okay. So what we've done is we've said the hello, what's up? We're making breakout game in plain English from scratch. So currently we're trying to draw a rectangle, and the way we're drawing it, we're saying from this vertex to this one, to this one, to this one. This is one triangle, and then the other is from here to here to here to here. And we have a rectangle. Like, ignore my drawing. It's a rectangle, or more precisely a square. So let's declare array vertices of type float and size. Do we actually need a size? No, we don't need a size. Array. Declare array. Yeah, we can just... Yeah, we can just declare a float array. Vertices, and the value is this one. Vertices with color values and texture coordinates. We have the float array, and now we have to just create a vertex array object, a vertex buffer object, and we need to yeah, that's about it. So let's create our VAO. And let's find the code for working with VAOs. So we need to create vertex array object and store it in VAO. And we need to bind it. Bind VAO bind vertex array object. And now we need to create a VBO. Where's the code for VBOs? Yeah. Create a vertex buffer object VBO. We need to bind VBO. And we need to give it the actual data. Copy vertex data from vertices to currently bound VBO. And we need to tell it how to interpret the data so it can draw it properly. Where did I'm just looking how to call it, how I've written it. I think it was called attribute. Yeah. Put in vertex attribute location 0 with size, it should be 2. Offset, offset is 0. This looks like you're writing an essay. We're actually making a game. We're making a game. But yeah, we're coding in plain English, so it's normal to look like writing an essay. And stride. So for the stride, it should be it should be like size of float times let me see, size of, do I have? Oh yeah. So size of float times and how much data do we have per vertex? Here we have, so for the position, we actually have this 0 value. We'll ignore it. We'll delete it. This is for the Z direction. We don't need it because it's always 0. We don't need it. Let's delete this one as well. So now, for each vertex, we have 1, 2, 3, 4, 5, 6, 7. We have 7 for each vertex. So the stride should be 7. 7 floats. Should be 7 floats. Should be 7 floats, and this is, we've told OpenGL how to interpret just the position. We need to tell it for the color and for the texture coordinates. So what we did here, we have to do it 2 more times, and we'll just copy and paste it. Here, copy, paste. Here, this is for the, instead of the 0 attributes, the first one. When we go to the shader, it will make sense what this location is. The 0, first and second. Here the size will be 3. It will be 3 because here the colors are 3 float values. Here it was 2 because the position are just 2 float values. So here size of 3, and starting from this offset should be a value. Offset size of float times 2. So we're changing the offset to ignore the first 2 values, to skip them, and to start from here for the color. And the stride is the same. It's just 7 values. 3, 4, 5, 6, 7. Yeah, 7 values. Yeah, that's it. And so now for the texture coordinates, are you converting a working script to English? We're converting this whole thing to the left. We're converting it to C++. This is what it's compiling to. So it's just a combination of the blocks to the right. Like it's literally just copy pasting from the right to the left with the arguments we're giving it. Just so all of this, what it accomplishes is that we don't have to remember the complicated syntax. And you can use it without knowing C++ as well. And this is so I can just focus on OpenGL and ignore the complicated syntax. And when I'm comfortable with OpenGL, I switch to just C++. Think of it like training wheels for riding a bike, but here it's training wheels for actually coding. Here we need the offset. We need an offset. The left side makes my brain hurt. Well, it will be just for this stream. For the other streams, I'm using just OpenGL and C++. So here, the offset should be 5. And yeah, and here size 2. And here starting from offset. Let's see if compiles correctly, if there are any errors. Okay, here bind buffer VBO. It has an issue here because I'm saying with capital letters VBO. Now it should be all right. Does this work? A vertex attribute. This is the first one. We need the others as well. But it's not. It should be like this. And it compiled it. Why is it pasting it there? I think the issue is... Oh, come on. It's having an issue with how much I indented. It should be like this. Like this. Yeah, I have to fix up the indenting. Like, I made this project a year ago, and I made it a year ago, and I made it again from scratch. I'm just setting up my microphone right now because I had to stand up. Like this. Okay. Yeah. I made it a year ago. It's not perfect. And I recently made this is the second version. Here, it has to be indented like the same everywhere. It has to have the same indenting. Now, is it solved? Should be solved. Yeah, here they are. When it's the same indenting, it works. What else? We have to draw it. Draw triangles from VBO using 6 number of vertices starting from 0. And let's run it. What's the issue? Okay, here our error reporting works. We have, oh, I see. Function main is already defined. Vertex shader. We haven't changed the vertex shaders. Vertex info. looking field. Vertex. I want the source code of the shaders because I didn't change them at all. Fragment shader source code. Here's the fragment shader and the vertex shader. Where's the vertex shader? And this is the vertex shader source code. This takes in the position, and it should be vector 2. This takes in the color. I'll change it to a color, and I need one for the position. Texture coordinates. And the texture coordinates we will ignore for now. Vertex color. And here it's like this for the vertex color. And position. Yeah, for the position, we actually need, for the Z, it's always 0. It's always 0 for the Z. That should be the vertex and the fragment shader. We are taking in the vertex color and we are setting it here. It should be all right. I need to compile it and run it and see if I'm missing something. It's already defined at 6. Okay. Error vertex info. Function main is already defined. How is function main already defined? Void main. It's telling me function main. So function main is this. This is the function main. And it's saying it's already defined. Oh. Oh, come on. I think I found my mistake. Vertex here, it should be fragment shader. What else? Okay, so this is fragment shader source code. I'm using it, right? Yeah, I'm using it. So we have our vertex shader. We create shader. We set the source code. We compile it, check for errors. Create fragment shader. Oh, when we attach them, no. Okay, it's looking all right. Then why? Let's see what function main. At 6, is 6 a location? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, it's probably for the vertex shader. It's probably for the vertex shader. Let's see on Google, but you might be trying to link 2 copies of the shader. How am I? Yeah, it's the shader program is having an issue and we are attaching the vertex and the fragment shader. We are linking them, and here's the issue. It cannot link them. It cannot link them. The vertex shader is using the fragment shader source code. So it's all right. Actually, let's do an experiment. let's change here the fragment shader to have a mistake. So we delete this. Let's have a mistake and see if it will catch it. Here, fragment shader, error, unexpected. Okay, so it's compiling the fragment shader. It's compiling the fragment shader. And now the vertex shader. Did it catch the error? A vertex shader is compiling the vertex shader. Perfect. It's compiling it. And here when we create the vertex shader, we create it, we set the source, and we compile it, and we check for errors. Here we create the fragment shader. Is this the issue actually? Oh, I see. That's the issue. It's a dumb issue. Create vertex shader. And here, create vertex shader object. That's the issue. It should be fragment shader. It should be fragment shader. Did it compile? Yeah, fragment shader. And we're drawing, but we're not using the shader. We need to use the shader. Use. We need to use it. Yeah. So activate is what I called it. Shader program. And now let's run it. And here we have a rectangle. After so much work, we have a rectangle. Before that, before we move on, we need to also render a texture. We need to render a texture. We need to render a texture. Oh, yeah, it's a rectangle. It's just two triangles. It's two triangles, and we are not done. We need to render this texture. This is the block texture. We need to render it. We need to render it. So here, yeah, set variable. Yeah, we need to load an image. Okay, we need to first think. Oh, we can set a git. So render square. Okay, we created a git commit. Just so if we mess something up. Never seen one of those before. Have you used OpenGL actually? So here we include image loader. We include the image loader. Texture. We declare variables for image loading. Yeah. So let's go down here. Down here. We need to, yeah, we need to do it here. We need to do it here. Declare variables for image loading. We need to load the image. And we need to load the image. And for loading the image here, it should be actually a resource path. So for the image, it's block texture, I think we called it. I think we called it block texture. In resources, block texture, PNG. So here, let's paste it. We load the image. Activate, generate texture. Yeah, but we need the texture variable. We need to store the actual texture, so we have to probably create an unsigned integer. We need a variable texture, I think, and we need to set a variable texture with texture object, and we need to activate texture unit, and I have to see what those were. But after that we need to bind the texture. Texture, we need to bind it. We need to load PNG image data to texture object, and we need to free image memory. We've created a texture object, but we need I need to find how it was called. GL texture, I think 0. How did we call it? I think I don't have it here. It should be called, let's open here, getting started, textures. I think geo texture, how should it be called? Okay, geo texture 0, like I expected. Activate texture unit, geo texture 0. So we've created a texture. We need to give it to the shader. Fragment shader source code. So here we need a uniform, I think. Yeah, we need a uniform. And for textures, I think it was sample 2D, texture 0, and new line. I'll leave it as that, and we will see if I'm correct. Yeah, it's uniform. Yeah, and here we want what do we want here? We want the color of the texture, and we need to store it in a variable. Can I declare a variable here? Can I declare vec for text color equals? We also need the texture coordinates as well. Texture 0, text coordinates, like this, and we need to give the texture coordinates. Here it's 2 text coordinates, and here we want text coordinates to be equal to a texture, what we're getting from the VBO, and this should be 2. I don't know why I set it as 3. a fragment shader, and now in the fragment shader, here for in, we are getting the text coordinates. We're getting the text coordinates and we are getting them here. And here we will actually multiply by text color. And we need to set the uniform. We need to set the uniform here. We will set it here, I think. Yeah. GL uniform. We don't actually need to set it, I think. Let's try. There's an error. Texture 0, undefined variable. Where? In the fragment shader. Oh, did I compile it? Yes, it's compiled. Texture 0. So fragment shader. Uniform texture 0. Undefined variable. Undefined. Uniform. Shader, linking fill, syntax error. I'm doing a mistake somewhere. It's hard to me to see where my mistake is. Unexpected and expecting. Should it be this like? Yeah, let's see. I think I'm doing the type wrong. Sample. I think I'm doing the type wrong. Sampler 2D. Sampler 2D. Oh my. Honestly. Oh. What's the error? Okay, it compiles. It compiles, it runs. But what's the issue? I'm wondering what's the issue. What's the issue? Is the stream running? Yeah. Stream is running. The problem is there's no error. There is no error. That's the issue. I'm not giving any error, and when there's no error, it's difficult for me to figure out what's the issue. It crashes instantly. Activating the share program. Where is the issue? We're loading the block texture. Can I let's experiment by removing the code for the creation of the texture. Okay, it's running. I found where the error is. Now we have to see what we're doing wrong. Let's. You know what? We can experiments. Yeah, we're doing an experiment. Let me open the chats because I almost missed your message. Where's the other chat? Yeah. Now we can actually open Visual Studio because there I have much better debugging. And here we will instantly see without a lot of experiments what's wrong. But it should be with the texture code. Remove this. It should be here. And we add a point here and we press start. Okay, it started. Now we go line by line and it will show me where the problem is. So step over, it generates the texture, activates the texture, binds it, and we're giving the data. And here is the error. Access violation. So giving the data was the problem, I think. Access violation. This is weird. We have our data. We load it. Width, height, channels. Then the texture. This is our current data. Current data, okay, it couldn't load it, I think. Block texture PNG. I think it couldn't load it. And we are not checking if it loaded correctly. Because the data, I think, is empty. You know what? Let's experiment with another experiment. Let's experiment with another texture. So in our textures, let's use the ball PNG. Okay. So the texture was the issue. This texture, I want to change it as well, but I don't want the block to the right. Block texture PNG. Why is it not? When I use the other one, it works. When I use this one, it doesn't work. Maybe because of the dimensions, because this is more of a rectangle. Texture, block texture. Block texture. Let's edit it. Let's edit the texture. Block texture. We'll open it with Krita and we'll edit. We'll change it. This is it. Now I want to make it smaller. How? Like this. Right? But how do we set this? Crop. Yeah. Height 28. Yeah. Crop. Perfect. Now it should probably work. Save, export, block texture, save. Okay. Now it should probably work. It should probably work. Okay, it's working. It's working, and let's set the color to... Let's change the color. Where did we set the color? Oh, we set it for each vertex. Vertices. Here. We've set it to the blue color. But... we'll be making changes actually, but let's keep it here as... Yeah, just once. It should be the white color. And here is the block. Here is the block. We have our block. We have our block. And now we want... What do we want? We want to actually set the position of the block. Set the position. Before that, we want to make change to the uniforms vertex shader. We need a projection matrix. We need a projection matrix. You'll see why. So here it's uniform matrix projection, and for the position we multiply by projection, and we need to set the uniform. Activate shader program. We activate the shader program, and we need geo uniform. Set uniform to matrix. Yeah, we need to create matrix. Set uniform, and the location is projection. Oh, sorry. Set uniform location to matrix projection, and the matrix is the projection matrix. Block is back. Yeah, the block is back. Set uniform projection matrix. Activate shader program. Yeah, we need to create the matrix. Identity. So we need to create the identity matrix projection. We've created it. And we need to... Actually, not the identity. It's not the identity. We need orthographic projection. We need orthographic projection. And the place I can access it... let me ban this viewer. I have a spammer in my Twitch chat. Have to ban this guy. You were banned. Okay, move on. Yeah, I forgot what I was doing. We need to the projection matrix. It's in orthographic projection, and this thing. We need this thing. We need this thing. So we will call it orthographic projection. Orthographic projection with width and height, and here it should be the width, and here it should be the height. Is this correctly? Because this will make it so the origin is at the bottom left, I think. Yeah. Which is different than usual, but we'll keep it like that. Yeah, let's keep it like that, and we'll see what's up. Orthographic projection. So we need to create a variable, declare a variable. We need a variable declare how did I declare? No, variable. Yeah. So we need a variable with name projection, type matrix 4. So type should be matrix, and value should be orthograph. Actually, orthographic projection width and height should be 1200 and height 900. I think did it work correctly? Projection. Yeah, it's having an issue doing it like this. We will we'll have it here. Orthographic projection 1200 and here 900. Yeah, that should be it. Geo uniform. For the location, it shouldn't be a string. It should be another function, get uniform location. So here set uniform, here should be, and store it in variable. Actually we can we can yeah, let's do it like that. Get uniform projection from shader program and store it in projection location, and here projection location. Okay. Now let's run it. What's the issue? Once again, no error. Oh, I see. Now it's probably working, but the size is too small. We need to actually transform it. We need vertex shader. Here we need another matrix, transform matrix. And here we need to multiply by it. And here we need to create it. Identity. Create identity matrix transform. And we need to scale it. We need to scale matrix. Transform. And here the scale should be like, let's say 10. Oh, we are not setting it. Let's get we need to set the uniform. Transform location. Transform location to matrix. And that should be it. Do we have the block? Oh, we also need vertices here. Instead of the negative, should be positive. So the negative ones should be the negative values should be 0, and the positive should be 1, because we are multiplying by the perspective matrix, the orthographic one. Translate, run. What else are we missing? Let's scale a bit more. Maybe that's the issue. It shouldn't be that. For problems like this, we can call render doc, and we can launch my game, and we can launch, and here we can capture the screen. We capture the screen and we can check if something is rendering, and if we just cannot see it. Here we draw an array. Mesh viewer. Okay, I think we're actually drawing. Oh, but the actual values are negative ones. Let me change. Let's change the orthographic projection. And here, let's set the height to be here. And here to be from minus 1 to 1. I think it should be like that. And we need to compile. Okay. Block is back. The block is back. It's on the top left of the screen. All of this was just to set its location. Know where the box go. Here it is. Oh, you switched from YouTube to Twitch? While you're in Twitch, how is it in Twitch? Is Twitch better experience as a viewer? Okay, we have the block. We have the block. Now we want to have multiple blocks. We want to have multiple blocks, but before that, I want us to clean up all of this by creating a class, a game object class. Okay, here, projection and transform matrix. I want to create a class, game object class, that automates loading textures, etc. The shader, we can leave it as that. We don't need to bother abstracting it. We need a game object. We need a game object. Here, do I have something for class? For create class. Yeah. Here. Create class. Let's create class. Game object with public members. Now, what should the game object have? It should have a default constructor. I think just a default constructor. I made some change here. What did I change? Class name. Okay, default constructor. Yeah, I just have this. I'll need to make another one. I need another default constructor for class with definition. And I don't want to call another constructor. Here, like this. So here, default constructor for class with definition, and we set the definition. So in the default constructor, what should be? We need also the VO. So here, a variable VO of type non-negative numbers. Non-negative whole numbers. And the class name is game object. Yeah. Now, default constructor, we want to, it should also have a transformation matrix. Yeah, transformation matrix. So variable transform variable transform of type matrix and what else? We want what else? Transformation matrix. Okay, in the default constructor we will initial we need also texture. Yeah, we need we need here texture. We need to store the texture, and so now in the default constructor, and we also need I think size, and we need position and scale on the X and Y. Right? Yeah, and it needs to be a vector 2 matrix. Here it should be a vector of size a vector of size. Yeah, let's check it. GLM vec2. I want to see how they call it. Vec2. I want to see how they call it. Two components vector. Two components vector. Vec2. Yeah, that's how they call it. So we want a variable that's called position of type two components vector, and we need scale. We also need, this is the position, scale. Yeah, that should be about it. Yeah, that should be enough. What else? And we will probably need different constructor that initialize all of these. Or let's leave it as a default constructor. Yeah, let's so what we will do is like this. Now inside the constructor we will declare the vertices vertices. But inside the vertices, we need to set the color. Oh, yeah, right. We need... No. We need another constructor with arguments. Constructor. Yeah. We need a constructor for game object with parameters and definition. So for parameters, we set what will be the parameters. We will want texture, but it will be texture path. So it should be variable. Texture path of type. The type should be char. What should be the... I'm wondering, when we give a string, what type is the string in C++? Variable, texture path of type. You know what? We can experiment. Here of type string with fixed size. We'll leave it as that texture path. We need to set the position, scale, and color. Color is 3 components vector. 3 components. Here, color. So texture path, yeah, we need to copy the color. Position argument, scale argument, and color argument. Oh, we... variable. Declare variable. The issue is that here it adds the semicolons to the right, and that's an issue. Oh, parameter. Yeah. It should be parameter. And now it's working. Now it's working. Okay. Now we need to actually do our job. So declare float array. Yeah, we declare the vertices. Now for the vertices, we need to be able to set the color. Texture coordinates is the whole texture. With color values, color, and here, here like this, and here like this. Color. Perfect. And here, here the value should change. The value. And here should be vertices. And with the color. Now the color should be actually, yeah, we don't need to set it. We don't need to save the color, I think. We don't need to save the color. The color here will be the default. No, it will be. How should it be? I think. Oh yeah. It should be. Can it be color argument? No, it will be color argument X. And then, no, it's red, green, and blue. Okay, perfect. Perfect. And this sets the vertices and color. Now we need to oh, I need to stand up. Let me fix the mic and let's check. Yeah, everything looks fine. Okay, now here we next we need to create this VO VBO. We need to paste it here. Here. This should be this variable. So we are declaring the vertices. We are creating the VO, then the VBO, binding the vertices, and telling how to use them. Okay. What else? We've created the VO. We need to create the texture now. We also need to set the position and scale. We'll do it here. Set variable value. How did I call? How did I change the value of a variable? Yeah, set variable value. So this should be the position to the position argument. Yeah. And then the scale to scale argument. Okay, now let's use the set the texture. For the texture here, we need to declare this and this. So here we need to paste it and I indent it. Declare variables for image loading. Load image, and here for the image we will use what did I call it? Texture path. Here texture path. We don't need to bind it. Bind texture allowed. Yeah, frame it. Okay. It's okay like that. And here here it should be image. Here resource path will remove it. Like this. It will be like this. I'm looking to the left constantly to check the stream if it's running properly or if there's somebody chatting. Okay, and now we need to create a function for drawing. We need also a default constructor, but I think we can test it out later. So we need function. So draw, function to draw with, I think shader. We will want the shader. Return value type of void. Okay, so arguments, it should be parameter shader program of type non-negative whole numbers. It should be number, but okay. What else? Definition. definition. And for the definition, we want when we draw, we want to activate and bind the texture. We need to do we want here to here we'll activate first the shader program. Here activate shader program. We need to activate it. We need to bind the texture. We need to create the transform matrix. So here activate shader. This is the projection. Create identity, transform. Okay. Here when we draw, we want to set the transform. We need to set the transform, and the transform will be, so here for this, we need to set the transform. We'll set it a bit later. When we draw, we need also I think this draw. Oh, we need to bind the, we need unbind. We're actually here, we need to unbind the VO, we need to unbind the vertex array object. And here we need here to bind the vertex array object, VO, and then here to draw it. And set uniform. Yeah, that should be it. Now for the transformations, we need to scale it properly. So scale matrix. Scale matrix transform by, and here it should be scale X, scale Y, and the Z I think should be just 1. And we also need to transform it, which should be after the scaling. Translate matrix by, and here we translate it by position X, position Y, and here on the Z by 0. That should be it. That should be it. And now we can create actually do create game object Create game object. Creating the game object, we will use the constructor. We'll use the constructor. So we need a texture path. So it's like, it's game object name, and inside here, with texture path, position, the position, position, scale, and color. So texture, position, scale, and color. So here we created start render loop. Let's create it here after the shader program. Create game object. So this will be just the block. Texture path will be block texture png. The position will be at 0, I think 0f, and the scale should be 100 on X and 100 on Y, and the color will be just white. Did it create it properly? Game object, okay. And now we will we call draw game object name using shader program name. So it's name draw shader program name, and here for texture path it should be resource path, and here draw game object, how do we call it, block using shader program. This should draw it. Oh, let's see what error is. Oh, I forgot this. I forgot the semicolon at the end. Let's run it now. And it's working. It's working. So now we can, oh my, it's working. Now we want to draw the blocks. We want to actually create the blocks. And now that we've abstracted it away, it's easy to create the blocks, because we just create a game object with the texture, position, scale, color. We will need a default constructor, but before that, we will need a default constructor. We want, like right now, I want a couple of blocks on a couple of rows. So we can do it as, like, how many blocks should be here? Like, let's set it as 10 blocks here and to have like 3 rows. 3 rows, 10 columns of blocks. Let's do that. And we'll change the color as well. So how will we do it? Now, I will do it as a rule. So it will be like for int I 0, I less than 10. We'll hard code it and then make it more easily accessible. I++. And inside we will create game objects. Oh, we need an array of them. We need a variable. We need a variable. We need variable of name blocks and type. The type should be game object array, but with reference. How is it? Did I do it correctly? Not quite sure. I think if I do it here like this, but is this array? CPP array of objects. Array of objects. How? Yeah, this is how they do it, but here it's fixed size and it's by the name. So it should be like this. Do incomplete. It's not allowed. Why isn't it allowed? Like I want to have, how do you create array of objects? Oh, I can use vector. Yeah, we can use a vector and we can create them and push them. Yes. So we want to also include a vector, include we want another include vectors. We want to include vectors and we want and we will set the type to the blocks as std vector game object. It should be fine now. Okay. And now here we say we create the game object. We say game. We say blocks. Like let's do it here. So for int I equals 0, I less than 10, I plus plus. So we blocks pushback game object. Is it new? And here like this. And here. Okay, and here it's resource path. And here the block texture PNG. Yeah, it's like what we did here. Oh, come on. It should be. Okay, young till closing bracket and here. Like that, like this. Now for the position, now the size is now we are doing 10 blocks, so 1200, so 100 and so here should be 100 and should be 1200 on its width, and for the position it should be I times 1200, right? And we test it out. Oh, we need to draw them. So here we delete this block, and here we copy this, paste it here, delete this here like this, blocks Can I do it like that? Draw shader program. Oh, it should be like this. Yeah. Okay, we're drawing them. Perfect. Perfect. Now let's abstract it away with rules. So this thing should be this should be great. Now it should be what? It should be create number of blocks, and here it's instead of 10 it's number of blocks. And here it's push back the texture. Yeah, this like that. But here it should be 1200 divided by number of blocks. And here as well, 1200 divided by number of blocks. And create number of blocks on row, and the row will be here. No, it should be here. So row times 100. This is the height with color. And here the actual color. And so here we will delete this game object, and here we create number of blocks. So number of blocks will be 10 on row 0 with color. This will be white. And we need to draw them. It's actually here it's actually blocks size here draw all the blocks using it's the using shader program name, shader program name, and here it's draw all the blocks using shader program. Now, why is it having an issue? Oh, the type. The type of the here it should be like this. Okay, let's run it. It's working, and let's change the blocks to 20 blocks. Maybe a bit too much. 15 blocks. Let's change it to 10. Let's see, 5. Let's change it to 8. Yeah, let's keep it 8. And here, let's change the color now to let's change the color. I need the color. Levels. Blue. I want the... Oh, but... Yeah. So... let's see what the colors are. So this blue one. The blue one. Okay, we see the value here. But I actually want it to be... for the color, I actually want it to be here when I set the color. Where do I set the color? Inside vertices. So here, and for the color, I will divide by 255. And here, if I set it to here instead of ones, it will be 255s. $255, $255. Okay, and now I can easily change it to 39, 39, 118, and 197, 197. And now when I run it, is this blue color. And now we can render 8 more blocks on row 1. And on row 2. And this color, what's actually the order? Yeah, let's get the green. It's just 1, 2, 4. 1, 2, 4. The green, and I need the orange one. Like this. So it's the orange, green, blue. Okay, we'll change the top one. We'll change the top one. 186. So 186, 93, 0, 0, and here they are. We have the blocks. We have the blocks and they're dynamically rendered. Perfect. Look at how awesome they are. And let's also add the background. Or we can leave it as black background. Yeah, we can leave it as black background. I was thinking of adding a background, but we'll see when we add the moving paddle. But this is it. This is it. Yeah, and maybe we'll have a quick break. Maybe we'll have a quick break. Yeah. I'm back. I'm back. Stand up. Yeah, everything should be working correctly. Let me set the microphone. Let me change. Yeah. Okay, we have our blocks. We have our blocks, and yeah, you can hear me. Everything is fine. Bringing back the chats. Twitch is here. YouTube is here. And yeah, so we have our blocks. Let's actually commit it. Blocks. And this is it. This remove. No. Okay. We have our blocks. We have our blocks, and yeah, okay, stream looks fine. Yeah, stream looks fine. Okay. We have our blocks. Next is the moving paddle. Next is the moving paddle. Yeah, so let's start with the moving paddle. Let's start with the moving paddle. We will want to create it. We'll create a game object. A variable here, create game object paddle with texture what's the texture for the paddle? Paddle png, paddle png, and position. Let's set the position at what should be the position? Let's set it as 1000 and then 400, let's just say. And the scale, we will have it at so let's have it at 50 on the Y and 100 on the X, and color it will be just white. And then let's here the name, it should be paddle or player, and here draw game object player using shader program. There's an error. Why did I make it like that? Create game object. Here I should have it like that. Like that. Like that. Like that. And here we compile and run. Okay, there's the paddle. Look at how small it is. We need to make it bigger. We need to make it, let's say 200. Okay, it's big enough. But look at how here, this thing here, this should be it should be transparent, and it's not. This is because in our shader, in our fragment shader, we have to discard those colors when the alpha is 0. Fragment. Here in the texture, if text color alpha is 0, we discard, right? Is it correct like this? Oh, we need like this, like this. Yeah, and now it's transparent, actually. Now it's actually transparent. Look at it. And it's pixelated. We can make it to be not pixelated like this. Yeah, we can do it to be not pixelated like this by just setting nearest. We need for the texture activate bind. This for drawing. No, we need for when we declare it. Bind texture, load it. Here. Here we set filter. And here set filter for when stretching. And here the filter is make it blurry. Make it blurry. And now it should be not pixelated. Probably. It's different. It's not that the difference is little. Look at how here it's big. It's like 2 pixels height. Here is 1 pixel height. It's not that it's more blurry. But the difference is quite minimal. But it looks better. It looks better. And now we have to position it properly. We need to position it properly. Let's create the paddle at now the position. The size is 50. So on the x-axis, we should, let's center it. So to center it, it's 600, but minus 100. So 500. And for the height, it should be 900, but minus 50. So 8, 5. And here it is at the bottom. and we will push it up a little bit, so 50 pixels up. And here it is. We have our paddle, but we want to move the paddle. We want to make it movable. We want to make it movable. We want to make it movable, right? Let me check. Yes, stream is running. You can hear me and see. Okay. Now we want to make the paddle movable. We want to make the paddle movable. How we will accomplish this? We will draw paddle. We will use the process input function with arguments player, and here if escape key, here if LNH, I'll use LNH, so H key and L key is pressed. So we want also velocity. Oh, we want delta time as well. We want delta time. We want delta time. So here, variable name and value. So here it's current time of type float and value 0. Previous time and delta time. And so here we call, we set variable and to value. So here we will set the current time to I think there should be time. Yeah. Time in seconds since glfw initialized. And we need to set the previous time to be what was current time. And here we need to set delta time to be current time minus previous time. Yeah, it should be like that. And then we give to the process input here delta time, like this. And in process input we get delta time of type float, and here player of type game object reference. And here, if is pressed, do action. Here the action will be, so if H key is pressed, okay, we need also a variable player velocity of type float, and value, let's set it as 100 f. And so the velocity, okay, and so when we have to update the set variable with value. So the name is actually player x to value player x plus player velocity times delta time. And here we do the same if the LK is pressed. So to the left is actually to the left will be minus, and here to the right is plus. And here I'm using H and L because those are the home row keys, because I use V motions, but I could have easily just set it as A and D for left and right. Now, does this work correctly? Player X has no member X. Okay, because game object has position. Position. Yeah. And here, position. And here it should be plus. And here was the issue. Process input. I think here should be a reference. So here it should be a reference. What's the, oh, I see. It should be like here where we create the game object, it should be new. Game object name equals new game object. Oh, and here it should be like this. And here, does it still have the issue? And person matches the argument list. Function argument types are glef, float, and game object. Yeah, here it's reference. Here for the draw, I have to sit down. Yeah. We're struggling a bit with C++, but we'll solve it. We will solve it. We're struggling a bit. Yeah, here for... Yeah, it should be working. Yeah, it's working correctly. Now here for... for drawing, it should be like this. Okay, and here, process input, game object, player, should be reference. Like, what? Oh, I see. No, I want here to be like... Yeah, I think... Yeah, it should be reference, I think, here. Okay, so... process input... No, actually... Here process input, here we set it as like this, and here we set it as like this, like this, and then we run it. Oh, come on, no. What's the issue? Function does not take 3 arguments. This is really confusing. When it's confusing, just open this and let's see what the actual issue is. Error list. Game object. Undeclared identifier. Yeah, but we're setting it. Is it because game object is here and we should move it down? Let's move process input here. And here. Okay. And now let's here let's change it back to I want it to be like this, and here I want it to be like this. Here like this. Now it should be finally working correctly. Process input should be working correctly. Okay. And here we're moving the paddle. Finally. Finally we're moving the paddle. Let's make it faster. Here let's make it 500. Okay. Perfect. Now we have movable paddle. We have a movable pedal. Oh, and next we want to spawn moving ball. We want to spawn the moving ball. Yeah. We will spawn it. Okay, let's move to the next one. We will spawn it here at the center of the game where we spawn the paddle, and the ball will move instantly, like at a random direction, either right or left. And that will be the start of it. Yeah. And we'll change it in the render loop. We'll change the render loop. We'll change in the render loop. Yeah, let me check in the chat. Working, stream working. Okay. Let's save it. Movable paddle. And next we want to spawn the moving ball. We'll do that by first creating it. So let's first create it. Let's create it with the what's the resource called? I think Smiley. What should it be called? Let me open these ones in File Explorer. Ball PNG, okay. Ball PNG, and it will be the position. This is 600, and to center it, okay. Let's make it 50-50. And let's set it at here 550 and here 750. Oh, we need to draw it and need to rename this ball, and here we need to draw the ball. And here we have the ball working, but it's not actually centered. It's not centered, it's more to the left. Oh, I know. Here? No, here. here it should be 25, so 75. It should be 75, and when we run it, now it looks more centered. And now we need to have add to the ball a velocity, and yeah, we need to give it a velocity. We need to give it a velocity because right now it's stuck on one place. It's stuck on one place. We need to give it velocity. Okay, stream is working. We need to give it velocity. Yeah, let's set a variable. Let's set a variable. Where should we set it? After the process input. Here we can set a variable and value ball velocity of type 2 component. How did we call it? Two components, a vector and a value of so it should be like to move it upwards, it will be like 0 on the x, and on the y it should be minus, like this, and we can actually 100 or 500. Let's set it as 100. And here in the when we draw the ball, where do we actually draw it? Before we draw the ball, we will change set a variable. We will set the ball position to be ball position. Yeah, to be ball position plus ball velocity. I think it should be like that. Where's the issue? Of game object. Position. How is position not member of game object? Position. It's a member. Ball position. It's not a member of game object. Equals ball. Oh, oh, it's position. Where is the ball? Where is the ball? Where's the ball? Let's change the here to be like by 10. Oh, I'm not multiplying by delta time. I'm not multiplying by delta time. So here times delta time. Okay, and let's increase the speed. Let's increase the speed here to 300 units. Okay. And let's make it a little bit to the right. Let's say here 100. Okay. And now, or maybe 300 as well. Uh, 150. Okay. We'll leave it at that. And yeah, we have a moving ball. Let's move on to collisions. So first we will add collisions with the borders. We'll add the collisions with the borders. We'll add collisions with the borders. How we will do that? How we will do that? How we will do that? We can see we can, how will we do it? We can create a function that let's create a function. So here, let's create a function. But how will we handle? We can, yeah, but we will have to give arguments of the blocks. Yeah. How to do it? So, function handle ball collision with arguments return type void and definition. So arguments. So we need parameter ball of type game object. We need, let's leave it at just the ball, and then definition. Now for the definition, what we will check is if the ball is outside of the screen to the right. How do we check it? The problem is, like, I'm writing in plain English, so I have to think of how to do it. Like, usually it's just keyframe keyframe interval to high twitch. Yeah, I have to check with Twitch about that. Oh, you know what I can do? I have to stand up. Have to stand up. Have to stand up. Fixing the microphone now. I'm checking about Twitch. Keyframe interval. I want to check something with Twitch. Because it's complaining. Here for keyframe interval should be 2 seconds. Okay. Now it should stop complaining. And next, now we want here, what we actually need to check is, let me set this microphone. Okay, what we actually need to check is we need to check if the ball position if the ball position plus its width, its scale to the x, is greater than 1200, and then do something. Okay, let's just do a regular if. If condition so if condition is true, then execute code, and here we say if condition is true. Okay. So the condition that we're testing is the condition we are testing is if the ball position on x plus ball scale x is if it's greater or equal to 1200, then we execute block of code, which is to set the ball scale x. Oh no, I need set variable name, and here ball position. No, we need to set the scale x to be ball scale x times -1, right? And we need to call the function we need to call the function process. What did we call it? Handle bow collision. We need to call it handle bow collision with the arguments bow, handle bow collision. Okay. Now if we run it, it should collide. Oh, but it's not far enough to the right, so let's add to the upward. Let's add upwards collision. So upwards collision is to the y. If it's just the y. If it's less than or equal to 0, then we flip the y. And we start. It should collide upwards. What? Oh, I'm flipping the scale. Oh, it should be, where did I set the ball velocity? It should be ball velocity. And here, ball velocity. Yeah, I don't need this. And here, now it should run. What happened? Oh, I'm setting. Oh my. Let's run it again. Look. I should set ball velocity, not the scale. Ball velocity. Yo! It's colliding. And here it should be also if or ball position x is less than or equal to 0. And here it should be, no, actually it's here, or ball position y is greater or equal to 900, I think. But actually, so if we start it now, it will collide with the bottom of the screen as well. Oh, come on. It should collide with the bottom of the screen as well. Okay, it collided. But it's not. Oh, yeah. But it should be plus its size, plus its scale, but we don't want that. When it's outside of the screen on the bottom, it's game over. So we'll leave it like that. Now we want to have collision. We want to have collision with the paddle. We want to have collision with the paddle. Right now, when it collides upwards to the right, and here it misses the paddle. We want to add collision with it. How will we do that? If we want to check if the ball has collided, and then we need a resolution if it has collided. So we can check. We can. How do we do this? We can. Yeah, and it's only. So instead of me making noises, we can just print this and paste this here like this, and we can restart the game. Let's take the ball. Let's paste it. So now, can I clean it up? Like this? Like that. Let me remove this. Okay. So now, what we can do is just check if it collides on the top. If it collides on the top, and that could be just checking a single horizontal line, and so to check if the ball is like inside of the paddle x and x plus width, and to check for if there's collision between this horizontal line and this one. If there's a collision, to just also invert its trajectory. The problem with this way of doing it is that if it goes here, if it goes like this, it will miss it. Like this, it will miss it as well. Yeah, we can just check it if it's just colliding. The problem is if it's like this, it will collide, because I'm using a square, not a circle, but like it's just a simple game for one day. We can leave it as just square collision. So we can check if they have if two game objects have collided. The two game objects are these ones. So we will add a function. To check for collision with another game object. And actually we can add it in the actual game object. So here we can add a function. So here for the name, we can set it as is colliding with arguments, and return type bool, and function definition. Okay. Here we set arguments, parameter, other game object, and here game object star, and then we set the definition. The definition will be the actual collision check. The collision check that we will do is Hmm, we need to store them in booleans. We need to store them in booleans. We need to store them like here. What we do is, if it's how we handle the collision check is we check this. Let me set this, and we check these ones on horizontal collision. We check these lines, the x and the x plus width, x plus width, and we check if it's, and let's say the green one is left, the blue one is right. We check if the order is left, right, left, right, right. Or if the order is, can I highlight it? The issue is I cannot move them. Man, this would have been a lot better if I did it in Excalidraw like this. Like this. And here we copy it, paste it, and inside here we draw, like here, left, right, right, left. So in here we see if we can group, in here, can we group? I want to group these objects together so we can move them, but group selection, yeah, okay. So let's say the green is left, the blue is right. And what we're, oh, come on, I need to move, send, bring to front. So what we're checking is, like here, look at how it's left, right, no collision on the, it's on the y-axis actually. And here, left, right, no collision. But if it's left, right, it's collision. And if it's left, right, it's collision. So we're looking for this pattern. And it's the same on the other axis, on top, bottom. And we're checking if both are true. That's what we're checking. We're just checking the pattern. We're just checking a pattern. And we are checking a pattern. And it's just two conditionals. It's two conditionals. If this is before this, or this is before this, they're colliding. And okay, if this is before this and it's right is before this right. Yeah, we are checking for this specific pattern. This is one of it and this is the other. If this is before this and this is before this. Those are the two scenarios. Oh, but what if it's like this? Because I'm doing it. How should it be? Like if But if it's here, if, oh, okay. If this is to the left of this, and if this is to the right of this, we have collision. And if let's take a break. Let's take a quick break. Okay, I'm back. I'm back. Yeah, should be. Okay. We now have to set up the collision. Let's set up the collision. Okay, you can hear me here. Here, this is working. That's my camera for when standing up. Okay. Now, we want to set the collision. Now, how will we set up the collision? Now we want to check here. It's collide. We are checking on these axes. If here it's collision on this, we check it by if it's we check it by here if this is inside or if this is inside. If it's like this, both are inside, so it's okay. But if this is inside, if this is inside, or if both are inside, that's how we will check it on this axis. And then on this axis as well. Let's see now. Here we set it as how do we set it? We have to yeah, it's an if condition. So if other game object position x is, so the position x is the left. If the left is greater, should be equal. If it's equal, it's like this. Or here if it's equal. Let's keep it as equal. If position x is greater or equal than our position x, and other game object, like can we set it here to be other, just other, so it's less typing. Other, and if other game object position x is, if it's less than or equal to our position x plus scale on the x, or if other position x is other position x plus other scale x is, so now on the right side, if the right side is if it's greater or equal than our position dot x and other position x plus other scale x is less than or equal to our position dot x plus our scale dot x, If this is true, then we also need to set variable x collision of type bool and value false, and we need and we set the code to be set name, set variable name. So we set the x collision to be true, and we do the same thing on the y. So this is the y collision. We set it to true, and here this thing we change it to y, and this thing we change to y, and this thing we change to y. So is it correct? Because we just swapped them. Is it correct? Let's see if okay, we have audio, no drop frames. Perfect. Now is it correct? Now we're checking if the other y position is greater or equal. So here I need to delete this and this, this. So here once again, but this time it's top, bottom, and here we group them, only these ones. So here it should be like this. So if but if it's like this, yeah, we need to bring to front. If it's like this, it's player y, position y, if it's greater than our y, and its y is less than equal our y plus scale. Or the other is like this: if other y plus other scale y is more than our position y, and other y plus other scale y is less than or equal to position y plus scale y. Position y, scale y. Okay. We should have collisions working. We should have, yeah, is colliding with. Oh, we need to return. We need to return how to type it in English. It's a return value. And function and give a result value. And function give result, and the result should be x collision, and y collision. So they're colliding if both of these are true. That should be it. And now we check when we handle ball collision, we should give it access to the player. So call function here, we give the player as well. Handle ball collision. And here, player. And here we check if condition. So the condition is if ball is colliding with player, if it's true, then we just multiply by -1 the ball velocity x. And so mad. Should we run it? Will this work? What? Why didn't it work? So if ball is colliding with player, then execute. Okay, we can try if it's not colliding. I'm not sure why it didn't work. Weird. We can actually debug here and check. Yeah, but it will be called each frame. We cannot debug it actually. We cannot debug it. Where's the issue? X collision, Y collision. And they're colliding if both are true. And here and, or, and. If it's true, we set this to true. This to true. Is colliding with, okay. Ball velocity. Oh, it's missing in handle ball collision. It's missing. This, oh, I see. It's having an issue. If I remove this and this, it's working. Is game object 1 colliding with object 2, and it's object 1 is colliding with object 2, and here it should be condition, and here condition is game object ball colliding with player. No, it should be like object 1, and here object 2. Okay, now let's try it. Man, will this work? Hey! Why? Why? Why is it not working, man? Why is the collision not working? I'm doing it correctly. If ball is colliding with player, right? We set the ball velocity on the X. Oh, you know what? It should be on the Y. It should be on the Y. It should be on the Y. Oh, come on. Yeah, it should be on the Y-axis. And yeah, it should be on the Y-axis. It should be on the Y-axis, but I'm not sure. It's probably not colliding. Let me see out. Collision. Let's see when there is a collision. What? It collided? What? It collided once and now it doesn't. What? It's super weird collision. It collided. Maybe it's too far. What? What's this collision, man? What's this collision? Oh, it's inverted. No? What? Oh, I'm so confused. But it's okay. What this tells me is that my math is wrong. My math is wrong. But it should work. So we're checking if we have collision both on X and Y. Now, let's see where the issue is. Now we're checking if what we're doing is we're checking if it's like this, if it's ever like this, or like this, but we will not get a case like that. So like this, or like this. You know what we can do? Render doc. We can launch the game through here. We can capture. We can launch it through here. But somebody's messaging on Discord. Hi there, I'm stuck at this error when pasting. Okay, somebody is having an issue with the video that I have. I need to stand up. I cannot help my viewer right now because I'm streaming, but I'll help him after the stream. I'll help after the stream. Let me set up the mic. Okay. Now I need to also set this up. Longer session. Okay. Now here. Can I restart the game? Preview? No. I want capture 10 frames. And I have here we are debugging. We launch and we launch and we I don't have the time here to set this to capture 10 frames. What I want is to capture immediately when there is collision detection. Oh, you know what? I can do it. I know how to do it. We will launch it. Let's remove all of these. Let's launch it and let's see which frame the collision will happen. So 600 around, but I want, it goes too fast. It goes too fast. Here I can capture frames and I can look at them frame by frame. That's what I get, but I cannot. I cannot pause it at the time. Okay, let's just do it like this. If it's like, I think what can make it, let's see it like that. Okay, when it passed through here, it just passed. Let's try to make it slower. Ball velocity. Let me just type my viewer to wait after stream. Yeah, after stream. I am live now. Okay. Now, ball velocity. Let's set the velocity. Ball velocity. Let's set the velocity to be slower. And let's see if the problem is speed. Oh, come on, not that slow. Not that slow. Here, like this. Okay, now it should be a bit slower, probably. And let's see. Okay, it's not the issue, the speed. My calculations are just wrong. My calculations are wrong here. So we're checking if the other... You know what we can do? We can check if... Let's see if it's commutative. If is game here to say it as player, because other is the ball. Let's see if this makes the difference. I think this is different. Okay. Yeah, now it's working. Yeah. Now it's working. Perfect. Okay, we have collision with the player and walls. We now want collision with the blocks themselves. We want collisions with the blocks themselves. So we need reference to the blocks. Here, blocks, and it will be a vector game object. Game object, and here handle bow collision blocks. Now, is this correct? What's the issue? What's the issue? No stable user-defined conversion from std vector to std vector. Oh, it has to be handle ball. Here it should be like this. Okay, now it's working. Should I give it a reference of the vector? Is it making every time a copy? We can leave it like that, and if there's no problem, it will be okay like that. Now here we can go through each block. And yeah, let's set here a new rule for going through each element of an vector. Go through, iterate each element of vector, and it's just and execute code, and it's just this. It's just that. Here, instead of block size, it's the vector size. And here we execute the code. So now here, when we, here we, what do we do here? We, for the bow collision, we iterate each element of the blocks. So let's do that. Iterate. Why is it? Oh, iterate. Okay, let's reset the extension, and let's rules iterate. Okay, now it's working. Iterate through blocks, and oh, come on. Iterate through blocks, and then we execute the code. Okay, what code we will execute? We will check if condition, if now the condition is game object, and the game object is blocks I, if it's colliding with ball. If that is true, let's say print to console message, and we'll say std cout message std inline. We will print to console collision with block. Oh, and we can also invert. There is an issue. How do we do it? It has to collide with it, but there is an issue. We don't know if it collides, right? Like right now, the collision check we are doing is like this. We are checking I cannot bring out a block. Let's bring out this block. Now, what we're doing is we're checking if there is a oh, come on. Why is it always to the back? We're checking if there is a collision. The problem is that and when there's a collision, we will just remove the block and just invert its y velocity. So it will be like this removed, and that. Like easy. The issue is that if it's coming like this, it should be inverted the x instead of the y. But we are always just checking if there is just a collision. We're not checking if it's through here or through here. And if it's like this, like it inverts the y, and here inverts the y, no problem. It will work. But here it should invert the x when it's to the left and from the right. What do we do, chat? What do we do? Here this is working. What do we do here? How do we handle this? So we, like, there is collision. We can check if we can, like, the default will be inverting the y, and if the player x is to the left or player x plus width is to the right, we invert x. Yeah. So we're keeping it at just checking collision. And here we have to do another if. and also have an else. If else code, else code. So here if condition else. Now the condition, what is the condition? The condition is if the ball position x is less than blocks I position x less than or equal to, or if ball position x plus ball scale x is greater or equal than block I position x plus block I scale x. If this is true, we execute some code, else some other code. Now, if this is true, we invert we invert on the x. Else we invert on the y. Let's run it like that. Oh, come on, what's the issue? Oh yeah, for the block it should be dereferencing it here as well, and here as well. And here should be blocks. And I have to increase the ball y, the starting position of the ball, because it's colliding still. The ball y will be 25. Okay, it's colliding with the block, and when it's colliding, okay, we need to set if should render, if should render of type bool. Actually variable and value. So here should render type bool true, default value. And inside when we draw, okay, should draw. Let's set it as should draw. And inside our draw, if condition, if should draw, if it shouldn't draw code and function with result. It shouldn't. It should be end function here. It should be end function like this. End function. End function. Let me sit down. Like this. And let's do now if they handle bow collision. Handling bow collision will be here. We set we will stop drawing game object and its object should draw equals false, and here it should be stop drawing blocks I. Done. Why is this an issue? Oh, okay. It should be dereferenced. Oh, not restart. Translate. What's the issue? Why is it not translating? Oh, rules. Now let's start. What? Should draw is true if, oh, okay. If what? Why is it like if should draw true? And this is true, and with this false, it shouldn't be an issue, right? Oh, it thinks that it has collided with them. Handle bow collision, and here we'll print to console collision with block. It by the start it has collided with all of them. This is super. We also need to, when we check collision, also in collision we have to check if either of them shouldn't be drawn. We ignore collision checks. if condition. So the condition is if should draw here, if this shouldn't be drawn or other should draw we want it to end function. So now, we need actually to return end function and give false. Now it shouldn't collide with them. Perfect. But how did it collide with all of the blocks? That's what I'm wondering. It has already collided with all of them. How so? Handle ball collision. How has the ball collided with all of them? I've created them. How has it collided, man? How has it collided? Here we iterate through each block. You know what? We can try, like for handle ball collision, we can give here a reference. And here, yeah, and no, we can just leave it here as that. Like here we can remove this, and here we can say a reference to this. CPRef pass a vector by a reference. Oh, okay. I'm just writing it wrong. Here it should be like that. It's still the same. It has collided with the block. Okay, let's see how the code executes. First we create the player, then we create the ball, then we activate shader program. Oh, here we create the blocks. And here we create the ball. Fine. They shouldn't be colliding. And we handle ball collisions here. We handle ball collisions. Let me open chats. We handle ball collision. we check the collision with the ball. You know what? Let's add another block. Let's do an experiment. Let's create create block. No. Create game object test block with texture block texture png. Position will be I want it to be below the ball, so let's set it as 500 and 800 and scale. What's the scale? 1200, 100, and color. And let's and let's draw it. Oh yeah, but actually I just want it to be added to add element to vector push back element. Create game object. So now add element test block to blocks. And let's remove handle ball collision. Here it is. So here, even if I put it here or here, the ball has collided with all of the blocks in some way. We can try here if ball has collided like this. It's still the same thing. So only time, okay, we can remove all of these and we can try without it. Okay, so the issue is here. We iterate through each block and let's, if condition is true, here we can say plus I plus why is it outputting it like that? Collision with block. It should output a number. Why is it not outputting a number? Like 12. Oh, because no, it should output a number. Is it constantly colliding? If it were to constantly collide, it would constantly change the velocity. It would constantly change the velocity. Stop drawing game object. CPP convert into string. CP print integer. You know what we can try? We can try like this. And here we set the I. And we start. And look at it. It's colliding with all of the blocks constantly. Oh, I'm the stupidest person on earth, man. This should be like here. Finally. Finally. Oh, come on. Finally. Okay. Let's remove our test block. Draw. No, we create game object test block. Finally, man. Finally. Finally, we have collision working. Finally, man. Man, this was so much work. Oh, and on the x-axis, I think it's working. Yeah, it's properly colliding on the x-axis. Like it's properly changing the velocity on the x-axis. Finally, man. This was so much work. Can I full screen it? Oh, but I didn't do the viewport change. Man, this was so much work. Let's increase the ball speed of ball velocity. Ball where is, yeah, here how can we increase the speed? We can change this to 200 and this to 400. It's not perfect. As I made it faster, I think it's going through some of the blocks. It's good enough. It's good enough. Now let's add game over and game win. It will just close the program when it's game over or game win. So to get that, we can do git add. Let's first commit. Git commit ball collision. Ball collision. Yeah, okay. So we can handle ball. We can go to handle ball collision and we can check if here like this, we copy that, and here we check if the ball position is greater or equal to plus ball scale dot y. If it's greater or equal than 1200, we close program. Now if we don't catch it, what's the issue? Oh, we need access to the window. Handlebar window, process input. We need here window. If am I doing it correctly? If the ball position y plus its scale y, oh, it's or equal. Now the game closes, but actually should be, yeah. Okay. The game closes. And now we also need to check. We need to check here, iterate each element of blocks code, and we check if, so we set a variable, win has won of type bool and the value false if condition, if blocks I should draw, then then code we set variable, we set has won to false, and after the iteration, if condition, if has won, we have to move it here. if has one, code close program. Okay, this should be it. This should end the game. Now. Oh, what was that? Let's try to win the game. Let's try to win the game. It's there it collided on the X. Because the speed is too fast, the collision is not perfect. Because it's keeping, like on the next frame, it's too far out, and when it's too far out on the next frame, it has some weird results. How can I catch that one? Okay. And now it should close it. It's going through each block. Okay. It's what's the issue? It's iterating through. Okay, has one. It's false. If it should draw. If there is a block that should be drawn, we set. Oh, default value should be true. True. Okay. Now let's go to showcase. Now, here is the game we worked on. This is it. Here I missed the ball and the game closes. Here I catch the ball and there's collision. Actually, let's lower the ball velocity. It's too fast for my simple code. Here let's make it 300 and here 150. Now this is the showcase. We have collision. If we miss the ball, the game is over. It just closes the game. And if we catch the ball, there is collision with the wall, with the blocks, with the paddle. We can move the paddle left and right. It's not perfect. It's not perfect, but for a beginner like me, it's good enough. Especially trying to write in plain English everything. It's good enough. Yeah. I cannot make the ball faster because when it's in one frame not colliding and it's really close to the block, and on the next frame it's like when the speed is too fast, the next frame the ball is like it may skip the block itself. The camera changed. I need to. Okay. And oh, not this. Oh, come on. And the game is over. I just wanted to bring back my camera. We can showcase it again. It's too far down. Yeah, now it's okay. And this is the game. Another issue is that the ball, the collision I'm using for the ball, I'm using a square collider. I'm not using a circle collider for the ball. And the reason is that the collision for circle and rectangle is more complicated and I don't understand it, and I don't want to use an algorithm I don't understand when I'm learning. But when I'm actually trying to make a game, like, I'll use whatever I have to. When I'm learning, I like to use what I know. And here it's colliding like this. And one last block is left. One last block. Will we ever reach there? The issue is I don't have control over the ball because it just inverts the velocity. It just inverts the velocity. It's not that I have control, and like, I'm not sure if it will be even able to reach there. I think that the ball is stuck in predefined directions. And that block will never be reached. Well, that's the game. You win the game when you've destroyed all of the blocks. That's the game. Thank you for watching, and we'll see what we'll do for the next stream. And so that was the showcase. Goodbye. We're